Hello class, welcome to another session with Professor Choi. Today we are here to talk about continuous probability distributions. Now this is our statistics series, and now we're in the process of talking about what exactly is a continuous probability distribution. If you want to kind of keep up with this, by the way, you should be watching it in order. So previously we talked about what were probability distributions, and then before this, we also talked about what were discrete probability distributions. Now, a discrete probability distributions is a probability distribution that has distinct patterns because it's normally the result of counts, and you have numbers in the distribution that have gaps. A continuous probability distribution is usually a distribution that starts at some point and ends at some point, but within the distribution itself is continuous. So it doesn't have any gaps. Okay? Now what we're gonna do is we're gonna cover different probability distributions in the next following videos, and we're going to try to talk about how to use those and how to find probabilities for those distributions. Now today in particular we are here to talk about what is called a uniform distribution. Now a uniform distribution is a distribution where the probability is exactly the same at any point in the distribution. Okay? So it is the simplest type of continuous probability distributions. It is rectangular in shape, and every time you're dealing with continuous distributions you might want to draw it because it's really the best way to visualize it. Okay? So a continuous probability distribution, in this particular case a uniform distribution, kind of looks like this. It looks like a sort of rectangle. Right? Now the height of the rectangle is the probability of each individual minute or each individual point in there. I mean minute if it's time, for example. So the height of the distribution, P of x, is the probability of each individual point on the distribution, and you can find that probability by doing 1 divided by b minus a. B is the end point over here for the rectangle. A is the beginning point over here for the rectangle. Okay? So down here we have our base for the rectangle, and over here we have our height for the rectangle. Okay? What we're going to do now is we're going to go through an exercise to try to calculate probabilities for uniform probability distributions. Okay? And we're going to start with the simplest stuff, which is basically calculating the mean and the standard deviation. So let's work on this example. Let's say that the train service in downtown Choitopia shows up to the main station every 20 minutes. So in other words, there are multiple trains. As you probably know, when you get a train service or a bus service, there are multiple of them running around, and then usually they run around in exactly the same sort of time period. So in other words, one goes out and then 20 minutes later there's another one goes out, and then if you can try to keep it, moving, then everybody's kind of getting to the station at exactly the same time, like every 20 minutes or so. Okay? So in this particular case. So the train runs from 4 a.m. to 11 p.m. And believe it or not, again, for this particular example, it makes no difference. Alright, so the question is asking us, what is the mean time and standard deviation that someone has to wait for this particular train to show up? Okay? Now again, to visualize this, the best way to do it is to really use this. So use this information, you draw one of these, and then you plug in that information in here. So let's do that. Alright, so this is our base, that's our height. B is going to be the end point, so it's the maximum number of minutes that somebody has to wait, and the answer here is 20 minutes. To imagine this, imagine that you get to the station and the train is leaving exactly at the moment where you get to the station, you're like, oh. So then the most you have to wait should be 20 minutes, which is how long it takes for the next train to get here. Okay? Alright, now the least amount of time you have to wait in this particular case is 0. And again, this is the example of this is, imagine that you get to the station exactly when the train is leaving and you can just like walk into it, and that is, you waited no time at all. Alright? Now if you just like a little bit behind, then now you gotta wait 20 minutes because the train's gone and you just got there late. Alright, so now 20 will be our B, A will be 0. The probability of each individual minute, therefore, will be 1 over B minus A. So probability of each individual minute, actually let me do it in red so we can keep track that it has to do with the example. Alright, so probability of each individual minute is equal to 1 over 20 is our B, 0 is our A. Okay, so this is the same thing as 1 over 20, and I think it's 0.05, but let's make sure. Okay, so it's good. So it's 0.05. Alright, that's our probability of each individual minute. Now, let's try to tackle the questions that they're asking us. What is the mean time and standard deviation that someone has to wait? Alright, so this is how you calculate the mean for this probability distribution. So mean is equal to A plus B divided by 2. Now we know our A is 0, our B is 20, divided by 2, so that is 10. So the mean time that somebody has to wait for this train is 10. And that seems obvious, by the way, because it's basically 10. It's a number exactly in the middle between 0 and 20. Therefore, that is the average time or the mean time that somebody has to wait. All right. Now, what is our standard deviation? So standard deviation is equal to B minus A, so 20 minus 0, square, divided by 12, square root. Alright? And that is our standard deviation. So let me calculate that. Alright, so far I got that. 33.33. And then I gotta find the square root of that. And that is 5.77. Okay? So that is our mean and that is our standard deviation for this particular example. Let me write that down over here. So for this particular example, we have our mean equal to 10 and our standard deviation equal to 5.77. Alright, good so far? Now let's try tackling more fun questions. So let's go to question number 2. Imagine that somebody asks you, what is the probability that somebody's going to have to wait? So, what is the probability that someone has to wait between 15 and 20 minutes? So what is the probability that somebody has to wait between 15 and 20 minutes? Alright, so let's tackle this problem. We know that the probability of each individual minute, which is P of x, is equal to 0.05. So if I draw this one, we're at 0, 20, and the probability of each individual minute is 0.05. Now the question is asking me, what is the probability that somebody's going to wait between 15 and 20 minutes? So basically, they want to know what is the probability between 15 and 20. Now because this particular uniform distribution is a rectangle, then what the question is really asking you is what is the area, so what is the probability, what is the area between 15 and 20 minutes. Okay? So in order to calculate the area of a rectangle, the way to do it is basically to do base times height. Okay? So we do base times height in order to calculate this particular answer. Because in a continuous probability distribution, when they're asking you for a probability, what they're really asking you for is the area under the curve, or in this case, the area under the rectangle for that particular portion. So if the answer to this is equal to 20 minus 15, that's our base, and we're going to multiply that times 0.05, which is our height of our rectangle. So this is our height of the rectangle, and this is the base for our rectangle. So the answer to that should be 0.25. Alright? So the answer to what is the probability that someone has to wait between 15 and 20 minutes is 0.25. Alright, let's do another one. Let's change the question a little bit. Call it question number 3. What is the probability that someone has to wait between 10 and 17 minutes? Alright, so what is the probability that somebody has to wait between 10 and 17 minutes? Now, again, every time you're doing a continuous probability distribution, it's best to start with the graph. And now we've already kind of set up our graph over here, okay? So we're going to start with our setup graph. We know it's a rectangle. We know it ends at 20 and starts at 0. Then we know that the probability of each individual minute, which we already calculated here by doing 1 over b minus a, is equal to 0.05. So we know that this area, this p of x, is 0.05. Now, the question is asking us, what is the probability that somebody has to wait between 10 and 17 minutes? So we're going to be at 10 and all the way to 17. As I mentioned a little bit ago, every time you have a continuous probability distribution and they ask you for a probability, what they're really asking you for is what is the area under, in this case, the line. So what is the area of the rectangle in that question? Therefore, what they really want us to know, because this is a rectangle, is we need to do the area for that. And the way to calculate the area on a rectangle is to do base times height. So this is going to be our base, and this is going to be our height. So the answer to this question is 17 minus 10, that's our base, times our height, which is 0.05, or the probability of each individual minute. Okay? So this is equal to 0.35. That's the answer. Alright? I hope you had some fun today learning with Professor Choi about uniform continuous probability distributions. Have a good one.